Hey guys, in this video we're going to look at some geometric sequences and we're going to make some and see how they work and give you a really good introduction into how to work with geometric sequences. So first of all, a definition. A geometric sequence is an ordered list of numbers in which the ratio between each pair of consecutive terms or numbers in the list is the same. So let's go ahead and make something that, that looks like this. So an ordered list of numbers in which the ratio between each pair of consecutive terms or numbers is the same. What that means is when you divide each term by the previous one, you should get the same number every time because that would be a common ratio. So let's say we start with the number 3. And let's pick a number to multiply by 3. Let's say 4. 4 times 3 would be 12. So to go from 3 to 12, we multiply by 4. Well, if we do that again, we're going to get 48. We'll multiply by 4 again. So if we multiply by 4 again, we get 48. Now, if we take 48 and multiply by 4 again, we're going to get 192. And now what's happening is we're making a sequence where the ratio between each pair of consecutive terms or numbers is the same. 192 divided by 48 is 4. 48 divided by 12 is 4. 12 divided by 3 is 4. And that's how you make a geometric sequence. Now, the next slide here says, let a sub n be the nth term of a geometric sequence with the first term a sub 1 and common ratio r. The nth term is given by a sub n is equal to a sub 1 times r to the n minus 1, where n is a positive integer. So this really looks complicated and technical. Let's go back to our previous one we just made. 3, and then it was 12, 48, 192, ... It keeps going that way. Basically, if you take this sequence right here that we made, the geometric sequence, a sub n would be the name of the entire thing. N is the term number, and a sub n, the whole thing, is the value of that term. And so the first term, a sub 1 of our sequence was 3. So that would be 3 times r is the common ratio. And we said that the common ratio for ours is if we multiply by 4 each time, we will get the next term in a sequence. So that is our r. And a lot of times we'll put that in parentheses. And then we have an n minus 1 up here for our exponent. Now we can find any one of these that we want. For instance, the fourth term is 192, right? So if we do 3 times, well, let's do a sub 4. A sub 4 is equal to the fourth term. We want to get 192. 3 times 4 to the 4 minus 1. And there's a reason why that minus 1 is sitting there. So 4 minus 1 is 3. And so a sub 4 is going to be equal to 3 times 4 to the third power. A sub 4 is equal to 3 times 4 cubed is 64. And then 64 times 3 is going to be 192. So it does work. So the fourth term is 192. And you can do that to find any term you want. That's just a little example. Let's get into some word problems that are common EOC questions. This one says, in 2015, the average monthly electric bill for a customer in a county was $90. Each year, the average monthly customer bill decreased by 5%. Part A is write a function that represents the geometric sequence. Okay, so that would be a sub n is equal to, and now we have the first term. The first term is the starting value, which was 90. So we're going to put a 90 here, times, and now we have what's happening each month. Well, each month the bill is being decreased by 5%. So instead of 100%, there's going to be 95% left. So in the parentheses, our common ratio is going to be 0.95. And that's going to be raised to the n minus 1. Okay, so there's our function that represents the geometric sequence. Part B says, what will a customer's average monthly bill, electric bill be in 2022? So let's go back to what we just wrote. A sub n is equal to 90 times 0.95 to the n minus 1. 2022. So how many years are going to pass from 2015 to 2022? And the answer would be 7. So if 7 years pass, what we want to do is find the 7th term. So we're going to plug in a 7 for that n right there, and then we're going to simplify. So a sub 7, which would be 2022, is equal to 90 times 0.95 to the 7 minus 1, which happens to be 6. Now it's going to get kind of complicated number-wise, because this is going to be, like we've seen before, a big long decimal. So let's bring our calculator in here, and let's do 0.95 raised to the 6th power, and we get a big long decimal, 0.7350918991, probably keeps going. We're going to multiply it by 90, and we get 66.158, and so that should be actually $66.16. So we're going to say $66.16 for that one, and then we should be good. All right. The only thing that, if you look at this question, the only thing that could be a little bit confusing, and they usually give you a little bit of leeway on the EOC, is that they say that in 2015, the average monthly bill was $90. So if you actually go 2015, 2016, 2017, if you actually go through the years, somebody could make the argument that n would be 8 because you're not really counting 2015. 2015 would be like year 0, right? And so somebody could make the argument that from 2015 to 2022, there's actually 8, and then you would just, instead of that 7, make that an 8. And I've seen that happen before, and the EOCs, usually, standardized tests usually give you a leeway of usually 1 a lot of times. So I really wouldn't worry about that right now. The big thing though with this is making sure that you can write this expression like that right there. That's the major thing. All right, so now let's take a look at this one. This one says a culture of bacteria initially contains 200 bacteria. If the number of bacteria doubles every 2 hours, how many bacteria will be in the culture at the end of 12 hours? This one's a little tricky. This one's tricky because at 0 hours, a sub 0, right? We don't really like to use 0 as a term number. We like to use 1. But if you think about this, it actually has 200 bacteria at the beginning, and it doubles every 2 hours. So let's do this. It's got let's say it's 0 hours. Let's make a t-table, hours. And then let's do bacteria. Okay, so for hours, at 0 hours, there's 200 bacteria. At 2 hours, there's 400, because it doubles every 2 hours. 4 hours, there's 800. At 6 hours, right, there would be 1,600. And then if we keep going, let's just get this out here to check. 8 hours should be 3,200. At 10 hours, 6,400. And then at 12 hours, 12800, 12,800. Don't need that. All right, now that seems to be the problem. The answer to the problem: at the end of 12 hours, you have 12,800 bacteria. If they have you write the sequence, though, that may be a little more challenging. So if you write the sequence, you're going to have to account for the number of hours, 0, 2, 4, 6, 8, 10, 12. And so you might have to just kind of take your n value and understand that it's being doubled every 2 hours, not every 1 hour. But that's the answer to that question right there. And it's a geometric sequence because for these number of hours here, the bacteria are going up and they have a common ratio every time. All right, this one says, if each foot of water in a lake screens out 60% of the light above, what percent of the light passes through 5 feet of water? This one should be kind of interesting. At 0 feet, you have 1, right? So, and why do I write 1? Because 1 is 100%. So at 0 feet, you get 100% of the light coming in. That is no problem. At 1 foot, if it screens out 60%, there's going to be 40% left, 0.4. At 2 feet, it's going to be 0.16 because there's another 40% of 40%. 40% of 40% is 0.4 times 0.4, which is 0.16. And you're just going to keep doing that. You're going to keep multiplying by 0.4 each time. So let's see if a sub n is now equal to, and it would be 1, right? Because 100% times 0.4. And then we're going to say to the n, and normally we would say n minus 1, but this time, if n is 0, right, then you're going to get 0.4 to the 0, and you get your 1 back. So in some cases, you do, instead of n minus 1, you just put an n there. It depends on what your situation looks like, if you're starting at 0 or if you're starting at 1. This time we're starting at 0, so it's just going to be an n right there. So now if we want to calculate a sub 5, for 5 feet of water, we do basically 1 times 0.4 to the 5th power, and that's going to be equal to, and we could do that on here, 0.4 raised to the 5th power, 0.01024, so 0.01024, and that's about 1.024%, which is not much at all. That must be a really murky lake. All right, next problem. A mine worker discovers an ore sample containing 500 milligrams of radioactive material. It's discovered that the radioactive material has a half-life of 1 day. Find the amount of radioactive material that will remain unchanged after 6 days. So if we want to write a geometric sequence for this, a sub n is equal to, we start with 500 milligrams, so that goes first, and then we have a common ratio of 1/2, since half of it every day is being decayed into something else. Okay, and then we're going to go to the nth power, this time not n minus 1, because this is our first value, and it's at basically day or time 0. So we're just going to do the n. Now, if we want to know 6 days, a sub 6 days is equal to 500 times 1/2 raised to the 6th power. And we can do that on here. So 1/2 is 0.5. Some kids will say, well, how do you put 1/2 in the calculator? 1 divided by 2 equals 0.5. Raised to the 6th equals, and then times 500. And I get 7.8125. So 7.8125. And then our units are going to be in milligrams. So the word problems for these, people don't like them because they're word problems, but they're not really that hard. You just usually wind up having to write a geometric sequence, which is almost exactly like an exponential function, and then using that by plugging a value in for n and then evaluating it and getting your answer. It's usually the same thing every time. So now let's go ahead and look at some specific skills with this. And the first one says, determine the values of the next 3 terms of each geometric sequence. So it goes 2, 4, 8. And so we try to find our common ratio. Our common ratio, we pick 2 of the terms and divide them. 4 divided by 2 would just be 2, which means the next 3 terms, you just take the previous term and multiply by 2. So 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. And that is it. This one goes 3, 3/2, and 3/4. So again, don't let the fractions bother you too much. So first thing you gotta do is find the common ratio. So let's do 3/2 divided by 3. So 3/2 divided by 3. If we do 3/2 divided by 3, we find that the 2 right here is going to flip down with the denominator and multiply. So it's going to be 3/6. And then that is going to be 1/2. So we have a common ratio of 1/2. So 3/4 times 1/2 would be 3/8, would be the next term. Next one after that, 3/16. Next one after that, 3/32, and that is it. Sometimes you're going to get ones that look like this, 4, 10, 25, and you just have to, again, divide. So the R, 10 divided by 4 is 10/4, and you always want to reduce 5/2. So now to find the next term, we just need to multiply by 5/2. So 25/1 times 5/2 would be 125/2. Same thing now, again, 125/2 times 5/2 would be 625/4. And just do it one more time. 625/4 times 5/2 is 3125/8. And these are the next 3 terms of our sequence. Okay, now we got this one. Again, we're going to divide to find the R value. R is going to be, let's say, 1/4 divided by 1/3. And if you're good at dividing fractions, basically what you're going to do is flip both of them. The 3 goes into the numerator, the 4 goes in the denominator, and it's actually 3/4. So to find the next term, 3/16 times 3/4 is going to be 9/64. Now we use 9/64 times 3/4 again, because that's a common ratio. And we get 27/256. And one more time, 27/256 times 3/4, common ratio. And we finally get 81/1024. And these are the next 3 terms of our sequence, and they get big in a hurry too. All right, let's see this one. Let's do 10 divided by 2 this time. You can take any one. 10 divided by 2 happens to be 5. So our common ratio is 5. So 10 times 5 is going to be 50. 50 times 5 is 250. And 250 times 5 one more time would be 1250. So these are the next 3 terms of our sequence. I know it looks weird because you start with a fraction, but I started with a fraction at the beginning of the sequence, so I knew what was going to happen, and it turned out nicely. And the last one for this set, let's do 1/2 divided by 2/3. Okay, so what's going to happen here? The 3 is going to jump up into the numerator. The 2 is going to go down below with that 2 and make a 4. And so 1/2 divided by 2/3 is actually going to be 3/4. And if you struggle with fractions, you're going to have to get good at it like what I just did. And the only way that happens is with practice. If you do 1/2 divided by 2/3, because we can't go back and do this every time. This is like a fifth grade skill. So 1/2 times flip, keep change flip, right? 3 times 1 is 3, 2 times 2 is 4. I still get 3/4. You gotta find a way to make this faster. So 3/8 now times 3/4 for our next term. And that's going to give us 9/32. Okay, we do it again. 9/32 times 3/4 gives us 27/128. And 27/128, oops, times 3/4 gives us 81/512. And those are our next three terms. All right, so here we go to a new type of problem. This one says to write an equation for the nth term of each geometric sequence. And so it goes 1, -4, 16, -64. So remember what it needs to look like. It needs to look like a sub n is equal to a sub 1 times r to the n minus 1, if you guys remember that. And already this marker is dying, so I gotta use another one. Okay, let's try this one. All right, so our first term is 1. Our common ratio, -4 divided by 1 is -4, basically. So we got a sub n is equal to 1 times and -4 to the n minus 1. And we're done. That's all you got to do. Okay, let's try this one. For this time, let's go ahead and list our a sub 1 and our r. That might help. A sub 1 is 5. R is 10 divided by 5 is 2. So this time we have a sub n equals 5 times 2 to the n minus 1. And that's it. All right, this one looks kind of interesting. So this time we do want our a sub 1 and we want our r. Well, a sub 1's easy, that's 136. But what's r? All right, so, well, let's just do 17 divided by 34 equals, and it is 0.5, so that's 1/2. Very nice. So this time we've got a sub n is equal to 136 times 1/2. And you could put 0.5 there if you want to, it'd be okay, to the n minus 1. Okay, this one, we have an a sub 1, a first term of -1/4. And now we've got to find an r value. Let's do 1/8 divided by -1/4. So 1/8 divided by -1/4. So we keep, change, flip. So keep, change, and flip. It looks like that is going to be -4/8, which is actually -1/2. So -1/2 is going to be it. So here's what we have then. A sub n is equal to -1/4 times -1/2 to the n minus 1, and that will be fine. That'll work. That'll give us any one of those terms of that sequence. All right, so now we have find the nth term of each geometric sequence described. These are a little bit tougher. Let's see if we can work these out. Let's see, we've got a sub 1 is 4, r is 3, and n is 6. So our formula then is going to be a sub n is equal to 4 times 3, common ratio, to the n minus 1. And we want to figure out what this is when n is 6. So when n is 6, okay, we're gonna have to do this probably on the calculator most of the time. So a sub 6 is equal to 4 times 3 to the 6 minus 1, which is 5. All right, so here we go. 3 to the 5th power equals, times 4 equals, and I get 972, and that is correct. And that's all we had to do. Okay, let's do this one. This time we get a sub n is equal to 45 times 1/3, and you can't cheat and make that a decimal either, to the n minus 1. And we want to know what happens when n is 3. So here we go. A sub 3 equals 45 times 1/3 to the 3 take away 1 is 2. That's not really too bad. 45 times 1/3 squared is really going to be 1/9. That is going to give us 45/9, which is going to be 5. So the third term for that one is going to be 5. Okay, this one we get a sub n is 72 times 6 to the n minus 1. N is 5 this time. So this is probably going to be a pretty big number. So a sub 5, 72 times 6 to the 5 take away 1 is 4. Okay, so 6 to the 4th equals times 72 equals 93312, and that is correct. Okay, next one. Okay, this time we got a sub n is equal to 4 times 1/8 to the n minus 1. We want n to be 7. So we've got a sub 7 is equal to 4 1/8. 7 take away 1 is 6. All right, now here's what's going to happen. 1 to the 6th power is just 1. What's 8 to the 6th power? 8 to the 6th power. Yikes. That is 2, 6, 2, 1, 4, 4. Big number. How many times does 4 go into that? Let's divide it by 4. 6, 5, 5, 3, 6. And so we're going to get 1/6, 5, 5, 3, 6. And that is correct. Okay, this one, throw some negatives in there for fun. A sub n is equal to -1/2 times -16 to the n minus 1. We want n to be 4. So a sub 4 is equal to -1/2 -16 to the 4 take away 1 is 3. So here we go, -1/2 times 16, make it negative, raise that to the 3rd power. It's -4096. And basically we're just going to divide that by 2. And then I got to make that negative also. And I get positive 2048. And that is correct. And just make sure the 2 negatives make a positive. And our last example looks pretty simple. Well, let's see how simple it is. 469. So, I got to find my stuff. A sub 1 is 4. R is 6 divided by 4, which is going to be 3/2. 9th power. Oh, that's going to be a big number. All right. Why do I do this to myself? Okay. Let's do a sub n is equal to 4 times 3/2 to the n minus 1. So that's my geometric sequence. And I'm going to plug in a 9 for that n, because I'm just a glutton for punishment. So I want the 9th term, 4 times 3/2. 9 take away 1 would be 8. Okay, so here's how we need to do this on the calculator. 4 times, we're going to have a fraction here. The 8 is going to distribute to the 3 and the 2 because of our rules of exponents. So 3 to the 8 is 6561 over 2 to the 8th, we all should know that's 256. Okay, now these two numbers here have nothing in common because they're just powers of two numbers that had nothing in common. And raising these to an exponent is not going to make them have anything in common. They're just more 3's and more 2's that never had anything in common to begin with. So that 4 now will cancel with the 256. So we're going to divide 256 by 4, and we're going to get 64. So the 65, 61 is going to stay, and then in the denominator, I'm going to get 64. So let me tell you why I did it that way, and that's the correct answer, by the way, instead of multiplying and then dividing. If I multiply 4 times 6561 equals, and then divide by 256, I'm kind of strapped with a decimal right there. So that decimal, I don't really see how that is 6561 over 64 right away, and I'd have to turn that into a fraction if I could, if my calculator can handle that, because once the numbers start getting kind of big on a lot of calculators, it won't handle turning them back into fractions anymore. So I would prefer just to take the 4, the 256, cancel those, get 64, and then just leave the 65, 61 sitting there, and that's to get my correct answer. So that is it for geometric sequences. Remember to like my video and subscribe to my channel if you haven't already. We'll see you guys later. Bye.